All right, let's get right into it. So in the previous lesson, we learned how to solve quadratic equations using factoring. This allowed us to calculate what we know, of course, as the x-intercepts. Now, x-intercepts go by a lot of different names, so let's cover a few of them. Sometimes you might see them called zeros, and this is to represent the fact that they are on the y is equal to 0 x-axis, right? So zeros is a common one. Another one is called roots. Now, called roots, honestly, I'm not sure why, but I could think of a couple of examples or a couple of reasons why, but I'm not positive of those reasons, to be perfectly honest. Maybe it has something to do with square roots when we get into later on this lesson today, which you'll see. But that is another term for it. Sometimes you'll see them called real roots. Real roots, as in the term a real number, as opposed to an imaginary number. We'll definitely come back to this shortly. But anyways, so when I ask you to solve a quadratic equation, what I'm asking you for is the x-intercepts, also known as the zeros or the roots. And I may ask you for any one of those three things, but they all mean the same thing. So we know how to do this already in a couple of different ways. We could, if our quadratic equation is given to us in standard form, something like this, y or 0 is equal to ax squared plus bx plus c, one method is to simply factor it. This is what we did in the last lesson. Factor it, and factor the equation, and then solve by setting each factor equal to 0, and we end up with our two terms. And this is great. We're going to get two values of x that make the equation true. Good. Another method, though, is we can actually put it into vertex form, and we could do the hard math and keep isolating and isolating for x, bringing the k over to the other side, dividing both sides by a, and then taking the square root of both sides, and then getting rid of that minus h. So this is by following Bedmas in reverse. Follow Bedmas in reverse. Just by isolating for x. So reverse to isolate for x. Now, whenever you do this, you're going to end up with a positive and negative square root of some kind, hence the term roots. So a positive or negative root. This is always going to be the case because you're going to have to get rid of that square at some point. So this is one strategy. That one may be a little bit more error prone because it's easy to make a mistake when you're rearranging equations doing this process, when you're trying to isolate for a variable. In this lesson, we're going to need to learn a third technique. This is something called the quadratic formula. And I'm going to tell you that you are going to use this so often for the rest of your mathematical career that 30 years later, it is still going to be ingrained in your mind, and you're never ever going to forget it, probably for your entire life, if you follow through with this and take any form of STEM field going forward. It's just commonly used so frequently. So anyways, so given some equation in standard form. So we're given an equation in standard form, ax squared plus bx plus c is equal to 0. Does it matter which side we put the 0 on? No, it doesn't, because it's a balanced equation. When we're doing quadratic equation, we usually like to put the 0 on the right-hand side, just for simplicity's sake. Now, our goal for this is we want to determine the value of a, the value of b, and the value of c. They're going to be integral to this whole thing. So we're going to arrange the equation so that all the terms are on one side are equal to 0, which we're going to put on the other side, as you see in the equation here. And again, it doesn't matter which side is which, as long as you've done it. Then we're going to identify all those coefficient values. The key here is they're the coefficient values multiplied by our key variable here. Okay, those a, b, and c. Usually I'll write them onto the side. I'll say something like a is equal to this, b is equal to this, and c is equal to that. And then once we have that, we are going to just simply substitute them into this equation and solve. You're like, what? That is a crazy equation, Mr. Lane. Yep. But just keep saying it to yourself in your mind, and you will have it memorized forever and a day. So here's the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, just substitute. That's it. All you have to do is recognize A, B, and C and substitute, and that's the whole work. So let's go give it a try. So I've given you lots of space to do this one, so make sure you use that space. We're definitely going to use the space on this document. So for this first question, we have 5x squared minus 7x plus 2. First goal, I want to identify A, B, and C. So A equals, B equals, and C equals. So in this case, A is equal to 5. B is equal to negative 7. Yes, the negative sign is going to come with it. And C is equal to 2. Now we just need to substitute. So let's write it. I don't normally write the whole equation out every single time, but for this first time I will. So we have x is equal to negative b plus or minus the square root. I usually don't write the top of the square root in until after I've written the whole thing out. That way I know how long to make the square root. B squared minus 4ac. Now I'll write the top of that square root in. There we go. And this is all over 2a. Now let's try substituting everything we got. We're trying to solve for x, so we don't touch that. X is equal to negative b, negative 7. I'll put the whole thing in here, but normally you're probably just going to write positive 7. Okay, plus or minus the square root of b squared, negative 7 squared, minus 4 times a, which is 5, times c, which is 2. Now I'm going to finish off that square root. And the whole thing is over 2 times a, which is 5. Now let's just do some math. So x is equal to negative times negative 7, that's just 7. Plus or minus. Now we have our square root. Negative 7 squared, that's 49. And now we have 4 times 5 is 20, times 2 is 40, so minus 40. That whole thing is going to be square rooted, and then we're going to divide by 2 times 5, which is 10. So let's simplify it a little bit further. So we have x is equal to 7 plus or minus the square root of 49 minus 40. That's the square root of 9 over 10. Oh, that's a nice number. So we have x is equal to 7 plus or minus 3. Square root of 9 is 3 over 10. Now you're like, so what do we do with this? What do we do with this plus or minus? That means that we have two possible answers. In one strategy, in the positive strategy, where it's a plus 3, and then we have another one where it's a minus 3. So we just calculate. X is equal to 7 plus 3 over 10. 7 plus 3, that's 10. 10 over 10 is just 1. Okay. Down here we have x is equal to 7 minus 3 over 10. So that's 7 minus 3, that's 4. 4 over 10 equals 2/5. Well, there's our solution. Those are our two x-intercepts. X is equal to 1 and x is equal to 2 over 5. That's the whole thing. Now you're like, that was a lot of work. Why don't we just factor that thing and find it that way? We absolutely could. Now sometimes the numbers aren't going to be so pretty though, and factoring becomes, if not an impossibility, a very large inconvenience. So you'll find that you'll end up probably using the quadratic formula more often than not in real world applications, because the real world doesn't care about how convenient it is for you. It just gives you numbers, and your job is to solve the problem regardless. So let's go on to the next one and give it a go. So we have our A, we have our B, and we have our C. So A is equal to 3, B is equal to 9, and C is equal to negative 2. Okay, let's get right into it this time. I'm not going to write out the whole equation this time. We're just going to write it out. So we have x is equal to negative b, so negative 9, plus or minus the square root of b squared, 9 squared, so 9 squared, minus 4 times a is 3, times c, which is negative 2. Now I'll top off the square root over here, and that's all over 2 times a, which is 3. So now here, let's finish off and clean up our math a little bit. X is equal to negative 9 plus or minus the square root. So we have 9 squared. That's 81. We know that. And that's going to be 4 times 3 is, well, it's negative 4 times 3. That's negative 12 times negative 2. So that's plus 24. Right? And finish off our square root. Now 2 times 3 is just 6. Let's clean it up a little bit further. X is equal to negative 9 plus or minus the square root of 81 plus 24. That's the square root of 105, and I can tell you right now that that is not a nice number. So what do we do in this case? Well, you calculate. The thing is, in some cases, your teacher may ask, keep it in exact numbers, in which case you leave it as the square root, and you're going to end up with a fraction as an end result, usually. But if they don't want exact numbers, then we use approximate numbers, and we have to just make sure that we use the correct notation for our equal signs when it is indeed approximate number. So in one situation, we are going the plus direction. Now in the another situation, we are going the minus direction. So over here we have x is equal to, in this case, we have negative 9 plus the square root of 105. And that's all over 6. Over here we have x is equal to negative 9 minus the square root of 105. And that's all over 6. Now these are still perfect numbers because I haven't done any math yet. But when you do this, what you're going to end up with is x is approximately equal to 0.2. And over here, we're going to have x is approximately equal to negative 3.2. Now you're probably asking yourself, should we reject any of these numbers? That one's a negative, sir. Well, no, because this is just math. We don't have an application of a problem here, so that negative number is just as valid as any other number. So we're not going to cancel anything out there. So you can see that the numbers aren't always just nice and work out kindly for us. Sometimes we have to do some extra work. All right, so let's look at the next one. So we have 2x squared plus 4x plus 3 is equal to 0. Now this is a quadratic equation, so we need to solve for this. Now, again, you could do the factored form strategy, and that might work. Maybe it won't. Let's find out what happens here. So in this case, we are going to find our a, b, and c. What is our a? Our a is equal to 2. Our b is equal to 4. And our c is equal to 3. So let's plug that into our equation. X is equal to negative b, so negative 4, plus or minus square root of b squared. So that's 4 squared. Minus 4 times a, which is 2, times c, which is 3. And that whole thing is square rooted. And then we divide that by 2 times a, which is 2. Now I'm going to tell you the same thing that you're probably asking yourself right now. Do I really have to write out all of the steps, Mr. Lane? No, you absolutely don't. If you want, instead of writing, say, for example, 4 squared, I could go right to 16 there. Instead of writing 2 times 2, I could go right to 4 there. It's probably a good idea to write out the whole 4ac each time, just because it's very easy to make a mistake there with the signs. It happens all the time, so just be careful of that part. All right, so let's put everything together. So x is equal to negative 4 plus or minus the square root. Now we have 4 squared, which is, of course, 16, minus 4 times 2, which is 8, and 8 times 3, which is 24, so minus 24. And that whole thing is over 4. So let's clean it up a little bit further. X is equal to negative 4 plus or minus the square root of negative 8. All over 4. What's the problem here? There's no such thing as the square root of negative 8. There's no two numbers that you can square and get negative 8. It just doesn't work, because any number times itself, if you have a negative times a negative, you're going to get a positive. If you get a positive times a positive, you're still going to get a positive. So this is what we call an imaginary number. You're like, what? What do you mean an imaginary number? Whenever you have a square root, there's more to this than just this explanation, but you'll learn more of that later on. But for now, for our sake, whenever you have a number that is less than 0 underneath that square root, this is what we call imaginary. It's not real. Now remember, the other term for our x-intercepts is called the real roots, and that's because it's made up of real numbers. So this is actually an imaginary number. So this makes for an impossible situation. So therefore, we have no real roots. what does that mean in terms of the graph? Does that mean you can't graph that? No, it just means that it doesn't touch the x-axis. When would it not touch the x-axis? Well, let's say we have a graph like this. Its vertex could be above the x-axis and it opens up, or below the x-axis and it opens down. And it doesn't really matter which side it's on or where it is. If it opens up and it's above that x-axis, it's never going to touch it. So in that case, you have no x-intercepts. Okay? So this is when we get no real roots. That doesn't mean the equation isn't valid. It just means that it has no real roots. Okay. So that's the core of the lesson. But let's carry on and do some more examples, and then we'll apply this a little bit. Okay? So let's move down. We got 3 more just straight quadratic equation questions, and then we'll branch out a little bit to a word problem. Okay, or some other problems, I should say, some other applications. So we have 2x squared plus 7 times x plus 1 equals 6. Is this equation is this a quadratic equation? No, not yet. We haven't put it into standard form and set that standard form equal to 0 yet. So our job is to simplify this. So what do we do when we see a situation like this? That means we have to we need to distribute that 7 through that set of brackets, and we need to get that 6 over to the other side because, remember, we need to set this whole thing equal to 0. So that means we have 2x squared plus 7 times x, which is 7x, plus 7 times 1 plus 7, and then we're going to bring that 6 over to the other side, so we have minus 6 is equal to 0. Now, please don't fall into the trap of constantly putting your equal signs over here, because that is wrong. Your equal sign is right here now. We now have a balanced equation, so we need to make sure that that stays like that. Okay? You can't just willy-nilly put equal signs anywhere you want. That's definitely a communication error. Okay, so let's simplify this. So we end up with 2x squared plus 7x, and then 7 minus 6 is just plus 1. And that whole thing is equal to 0. Now we're back to the state that we recognize and we understand. We have a quadratic equation, so let's solve it using the quadratic formula. In this case, our a is equal to 2, our b is equal to 7, and our c is equal to 1. So let's fill it in. We have x is equal to negative b, so negative 7, plus or minus the square root of b squared, so 7 squared, minus 4 times a, which is 2, times c, which is 1. We finish off our square root. Get our line here, and we got 2 times a, so 2 times 2. Okay? Now, you see how I just rattled off that equation. It's because it's ingrained in my mind, okay? I'm never going to forget it. You're never going to forget it once you get this down pat. Trust me. Okay, so now let's simplify our equation. X is equal to negative 7, plus or minus. Now let's see if we can do this a little bit quicker. So we know 7 squared is 49. And underneath, we have 4 times 2 times 1. 4 times 2 is 8 times 1 is still 8. So we have 49 minus 8. So this is the square root of 41. And that's all going to be over 4. So that's pretty tolerable. I guess we could do this. So in one case, we have our plus situation. And in the other situation, we have our minus. Now, some of you are like, where should I write that little plus or minus note? You don't even have to write it at all, to be perfectly honest. I do it because it helps me keep clear. Usually I will write a little arrow with a plus sign there and a little arrow with a minus sign. So this is just for my own communication purposes, and it keeps it super clear so there's never any question. That way if I ever have to go backtrack, I can clearly see what's going on just in case I made a mistake. So on the left-hand side, I have x is equal to negative 7 plus the square root of 41, all divided by 4. On the right-hand side, I have x is equal to negative 7 minus the square root of 41 all over 4. And now we solve. Now, 41 is not a nice even square root. That means I'm going to end up with an approximate value on both sides. Now, when you put this into your calculator, you're going to get, on the left-hand side, about negative 0.1, and on the right-hand side, about negative 3.4. Depending on how many decimal places we want to go to. But that was never specified, so we made a judgment call. Okay, let's go to the next one. So we need to simplify this equation, put it into standard form. So that means I got to get that 24x inside. So inside, I'm going to end up with 3x squared minus 24x plus 48 equals 0. Now, you're probably saying to yourself, there is clearly a GCF there. Yep, there is. So let's get rid of it. So let's divide everything here by 3. So that means we have 3 times x squared minus 8x plus, what's 48? 16? Yeah, 48 divided by 3 is 16 equals 0. Now, if I divide both sides by 3, we just end up with x squared minus 8x plus 16 is equal to 0. Ooh, we super simplified this. Now, what are our A's, our A, B, and C? A is equal to 1. Our B is equal to negative 8. And our C is equal to 16. Now, you're probably asking yourself, did I need to do that? Could I have just used these numbers here? Yep, you absolutely could have. Wouldn't be an error. It's just your numbers would be getting pretty big. And that's not usually something ideal because it's going to make the math a little bit more challenging going forward. So let's continue. So we have x is equal to negative b. So negative 8, that's just going to be 8. Plus or minus square root of negative 8 squared. Negative 8 squared is what? Negative 8 squared is 64, but I guess I'll write the whole thing here. Okay. And we're going to subtract from that 4 times 1 times 16. Okay. And underneath here, we have 2 times 1. Let's keep going. X is equal to 8 plus or minus the square root of 64 minus 64. And in this case, we have a 2 underneath. Whoa, 64 minus 64. Interesting. X is equal to negative 8 plus or minus the square root of 0 over 2. What does that actually mean? That means x is just equal to negative 8 over 2. So x is just equal to negative 4. Wait a second. How does that even happen? Well, let me undo that. It's very difficult to see. Oops. There we go. How does that actually even happen? What does that mean? Is it possible to only get one x-intercept? Yep, it certainly is. So in this case, what does that actually mean? It means we have one real root. But from a graph's perspective, what does that mean? That means if we have a graph, that means it only touched the x-axis at one point. That tells me that the vertex is on the x-axis somewhere. Whether it's opening up or down, it doesn't make a difference. The point is that that vertex is on the x-axis. Okay. So we've seen situations where we get two roots, such as this one. We saw on the previous example, a couple examples ago, we saw we had no roots, no real roots. And in this situation, we have one real root. So all these situations can still occur. All right, let's look at the next problem. We have 4x squared plus x minus 5 is equal to 2x minus 5. Well, we got to simplify. Let's multiply that and distribute first. So let's say 4x squared plus x minus 5. And on the other side, we have 2x minus 10. Now we got to bring all that over to the left-hand side. So we have 4x squared. And we have plus x. We're going to bring that 2x over. So we have minus 2x. And we have minus 5. And we're going to bring that minus 10 over. So we have plus 10. And that is equal to 0. Okay. Simplify this as much as you can. Oops, that should be 4x squared. You end up with 4x squared. X minus 2x is minus 1x. And then we have minus 5 plus 10 is going to give us plus 5 is equal to 0. Okay. So what is our A, B, and C? Our A is equal to 4. Our B is equal to negative 1. And our C is equal to 5. So let's substitute everything in. So we have x is equal to negative b. So negative 1. That's just 1. So let's just undo that little piece there. So, oops. X is just equal to 1 plus or minus the square root of, well, b squared. So negative 1 squared minus 4 times a. A is 4 times c, which is 5. Okay. Now, take the square root. I'm sure most of you can see exactly what's happening here. We got 2 times a, so 2 times 4. But let's carry it through. So we have 1 plus or minus the square root of, we have 1 minus 4 times 4 is 16, times 5 is 80. And that's all over 8. So we have x is equal to 1 plus or minus the square root of negative 79. Oops. And that's all over 8. But since we have a negative square root, we have an impossible situation. Therefore, no real roots. No x-intercepts. Okay. So that's the basics of how we're going to approach all these problems. But let's actually apply it to something a little bit more interesting now. So let's say we're given this equation here. X is equal to negative 3 plus or minus the square root of negative 23 all over 4. And I tell you, hey, put that, I want to know what the standard form equation is for this. Now, what do I mean by that? That means I want y is equal to a standard form equation. So y is actually going to be equal to 0 here. There we go. So what I'm looking for is 0 is equal to ax squared plus bx plus c. Well, the only way we can do this is if we can find a, b, and c. Now, we started with this equation right here. X is equal to negative 3 plus or minus negative 20, the square root of negative 23 all over 4. That certainly looks like the quadratic equation, which they tell us it is. So let's think about what the original quadratic, the general form, looks like. The general form is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, given what we can see up here, our job is to figure out what a, b, and c are. Well, the easiest one, of course, is b, because we can see that from the equation right here, negative 3, we know that the equation is negative b. So what does that tell us? That means negative b is equal to negative 3, which means b is just equal to 3. Okay, we're a third done. What else do we know that's nice and easy? We know that the bottom of the equation is 2a. Well, what is 2a equal to? 2a is equal to 4. Okay, so that means we just need to divide both sides by 2, and a is equal to 2. That means the only thing we're missing is c? Oh, great. So the only other part of the equation we haven't used yet is that negative 23. What's the negative 23 equal to? The negative 23 is equal to b squared minus 4ac. b squared minus 4ac is equal to negative 23 in the given equation. Let's substitute what we know. B is 3, so 3 squared minus 4 times a, which is 2, is equal to negative 23. Right? Oops, I forgot the c. I'm like, why am I missing a letter? Right there. There we go. Negative 23. So if we do the math, that's 3 squared is 9, minus 4 times 2. Oops, what's going on here? Minus 4 times 2, which is 8, so minus 8 c is equal to negative 23. Now our goal is to calculate for c. That means we need to isolate. So I need to bring the 9 over to the other side. So I have negative 8c is equal to negative 23 minus 9 is going to give me negative 32. So now I got to get rid of this negative 8, which is multiplying by c. So I need to divide both sides by negative 8. So c is going to be equal to negative 32 over negative 8. C is equal to 4. Okay, we've got all three values, so therefore 0, I guess we can write it in the opposite direction. So a, which is 2, x squared, plus bx, so b is 3, plus 3x, plus c, which is 4. It's going to be equal to 0. And that's the whole process. So when you're given an equation like this, you're just kind of using your mental math and relating it back to the original equation to figure out what you can pull out of it. And eventually you're going to have to do some substitution, but you will be able to get all three components of our standard form equation. So the next question down here, just below here, is more of just kind of like a description. It says, why are there no real roots? Why are there no real roots in this question? Can the equation be written in factored form and explained? First of all, we know there are no real roots because the square root has a negative underneath. That's undefined. It's not possible, right? It's an imaginary number. So we'll write this. There are no real roots because the square root of negative 23 is not a real number. And therefore unsolvable. Now the next part of the question says, can you write that equation in factored form? Well, it can't be written in factored form for the simple fact that you don't have x-intercepts, which means you'd never be able to get the terms. You'd never be able to get the terms required to put it into the proper format. You'd never be able to put in y is equal to a times x minus r times x minus s, which basically means the equation is simply unfactorable. And we've come into lots of examples in the past where our equations are unfactorable. It's just part of the way it is. So we're going to say it cannot be written in factored form because if we think of the original equation and our a, b, and c, what we have over here, if we're looking right at our equation here, because there are not two numbers that multiply to 8 and add to 3. They just don't exist. Right? 1 times 8, 2 times 4, that's it. So that is the end of our next lesson, which is 6.4. We're going to move on to 6.5 soon. This should give you all the tools you need now to solve our quadratic equations. So now we know how to find all the x-intercepts, and in a variety of ways we know how to find the vertex in a variety of ways, and we're going to start applying that soon. But we need to learn some shortcuts first. So that'll be the next lesson.